use the graph to find the equation of the line. So here we have a graph, and we see we have 2 points noted, -3, 5, and 1, 3. So if our goal is the equation y equals mx plus b, we know m is the slope, and b, remember, comes from the y-intercept, but we don't see the y-intercept clearly marked. So we're going to use a slightly different process here. We're going to find the slope, and we're going to use the slope and one of the points to identify the y-intercept. Alright, so let's find the slope. Alright, so m we'll find as rise over run. So from point to point, let's see, we move to the right. Oh, let's do the rise first. That's what we usually do. So we have -3, 5. So our rise then is that distance, which is down 2. So our rise then is -2. Our run is this distance, and our run then is right 4. So we'll think of that as a +4, and so that gives us, after reducing, a -1/2. Now notice, if you had just used the ordered pairs and the slope formula, we could have said m equals y2 minus y1 over x2 minus x1, and so that would have given us 3 minus 5 over 1 minus -3, which gives us -2 over +4, which is also -1/2. Alright, so we have the slope. So now what I can do is I can write a partial model. I can write my first revision in a sense. And so I can say that y equals -1/2 x plus b. Now, the thing is, I still have to figure out the b. So what I'm going to do is substitute one of the points on the line. It doesn't matter which one you choose, but I'm going to go with 1, 3. I'm going to substitute 1, 3 into that equation. So 3, the y value, would equal -1/2 of 1, the x value, plus b. Alright, so now we go through some arithmetic here. Let's see, 3 would equal, simplifying, -1/2 times 1 is -1/2 plus b. Solving for b. To solve for b here, I would add 1/2 to both sides. And I'm going to think of that as a decimal number 0.5, although I could think of it as a fraction. It doesn't really matter. And so then what we would find is b would equal 3 plus 1/2 is 3.5. And since that's an exact decimal, I'm going to go ahead and use the decimal, right? 1/2 is exactly 0.5. And so now that I have the b value, I can go ahead and make my newest revision to the model, and I can write y equals -1/2 x plus 3.5. Now, of course, if it wanted all fractions, I could convert that decimal number to a fraction. I could write y equals -1/2 x plus 7/2. So however we want it. So let's see another example. And so here I have this line that passes through the points -3, -14, and 7, 12. So rather than use the rise over run concept, I'm just going to use the slope formula in this situation. So then again, my goal is y equals mx plus b. I want the equation of the line. So let's first figure out the slope. So then m would equal y2 minus y1, 12, subtract -14, over x2 minus x1, 7, subtract -3. 12 minus -14 is 12 plus 14, that's 26. 7 subtract -3 is 10. And I'm going to go ahead and work solely in fractions for this example. And so I'll reduce the fraction to 13/5. So my new model is y equals 13/5 x plus b. Now, choose one of the points on the line. I'm going to go with 7/12. So then my y value, 12, would equal 13/5 of 7 plus b. 13/5 times 7, so that gives me 12 equals 91/5 plus b. Subtracting 91/5, now let's see, 12, let's do a little side work here. 12 is equal to 12 over 1, and building up that fraction by a factor of 5 gives me 60 over 5. And so then I can think of this 12 as 60 over 5. Subtract 91 over 5 is negative 31 over 5 is b. And so now that I have that b value, I can write y equals 13/5 x minus 31/5. Now, if you had decided to work in decimals, and there's nothing wrong with that because 13/5 or 26/10 is an exact decimal, so we could have worked exactly in decimals and we would have had y equals 2.6x minus 6.2.